In this video, I introduce a recurrent neural network. Recurrent neural network is a nonlinear sequence-to-sequence model. Here is a simple RNN model that includes three layers: input layer, hidden layer, and output layer. The RNN model uses a sequence of data as the input to predict the new sequence. To better understand the RNN model, we enroll the recurrent in time. We define the input unit, hidden state, and output unit together as a cell at a time t. So we have a cell at t equal 1, cell at t equal 2, and so on. Our model has a unique feature, namely all the cells share the same set of parameters W and B. We input a sequence of data to the model one by one in order. The model will produce a new sequence of data, Y1, Y2, and that's Y3, so on. The RNN model uses a one-hot vector as input to predict a dense vector. Namely, for example, we have x, x1 at t equal 1. And then we find this x t equal 1 in the location vector, find the location of x1. And then we set its corresponding location in the vector v1 and set all other entries be 0. And then we use this one-hot vector as an input to predict dense vector to describe the probability distribution of predictions over all the possible letters in the corpus. And then we select the data with maximum probability to get a desired output sequence. Here we show the propagation procedure inside the RNN model. For example, we have a previous hidden state at t minus 1. We have a current input at t. So we put them together with a shared bias as the input to update the current hidden state. And then use this current hidden state as the input to the output layer with this bias to predict a new output yt. And then we get this dense vector shows the probability distribution of prediction over all the possible letters in the corpus. Here, from this sigma function, we get the value between 0 and 1, but it is normalized by themselves. That means that between the data is no computation. What we need computation to select the data with maximum probability to get a new sequence. Here we use Y as a ground truth to train the RNN model in a supervised manner. To train the model, we need to define a loss function. Here first, at a time t, we use cross entropy as a loss function. Here, this is the label and this is the prediction. We define this cross entropy as a loss function to calculate the loss at a time t. Because we have a total, for example, tx time steps, to get the total loss, then we just add this loss at each time together to get the total loss. And then we use this total loss function to train the RNN model. For more details, please check with this reference. Thank you. Bye.